By the end of the Second World War, many German tank crews had learned to fear something they could not see. It was not the armor of the Sherman tank. It was not the power of its gun. It was not even the skill of the average American tank crew, though by 1944, those crews had become far more dangerous than the Germans had expected. It was the way American units seemed to move together. A Sherman would appear on one flank. Then another would fire from a second direction. Artillery would fall minutes after a target had been spotted. Infantry would move forward just as tanks shifted their fire. Commanders miles behind the line seemed to know what was happening before the Germans themselves could understand the battlefield. To the men fighting against it, this could feel like luck. Sometimes it looked like overwhelming numbers. Sometimes it looked like air power. Sometimes it looked like chaos somehow becoming order. But behind it was something simpler. A voice. A clear American voice in a headset moving through static, engine noise, artillery fire, smoke, and fog. The Americans did not win the war because of radio alone. No single machine won the Second World War. The war was decided by industry, fuel, logistics, air power, artillery, intelligence, training, manpower, and the slow exhaustion of the German army. But radio changed how those strengths reached the battlefield. And in the tank war of Western Europe, the American advantage in tactical communication became one of the quietest and most important advantages of all. This is the story of that invisible advantage. Not a magic weapon, not a secret supertank, not a miracle that made bad tactics good, but a network of men, machines, and voices that allowed an army to hear itself while the battlefield was trying to make every man deaf. And the story begins not in a tank, but with a man standing on a rooftop in the summer of 1933. His name was Edwin Howard Armstrong. By then, Armstrong was already one of the most important radio engineers alive. He had helped create the regenerative circuit. He had helped make the superheterodyne receiver practical. His work lived inside the radios of homes, cars, ships, aircraft, and military sets across the world. But in 1933, he was demonstrating something different. Frequency modulation, FM. For years, radio engineers had accepted static as a curse that could only be managed, never truly escaped. Lightning created static, engines created static, generators created static, electrical systems created static. A battlefield created more noise than almost any place on Earth. Most radio systems of the time used amplitude modulation. AM carried information in changes to the strength of a signal, but static also appeared as changes in signal strength. That meant noise and speech fought each other inside the receiver. Armstrong asked a different question. What if the voice did not ride on the strength of the wave? What if it rode on changes in frequency? If the receiver could ignore changes in amplitude, then much of the static that ruined AM communication could be pushed aside. Not eliminated in every condition, not turned into perfection, but dramatically reduced. For commercial broadcasting, FM promised cleaner sound. And for war, it promised something more valuable. Clarity. A tank is not a quiet machine. Its engine roars, its tracks grind, its turret motors whine, shells explode nearby, machine guns fire, men shout through steel walls. A tank commander trying to hear orders over a bad radio is not merely inconvenienced. He is blind in a moving iron box. And in armored warfare, blindness kills. Across the Atlantic, another man understood the importance of radio for tanks long before most armies did. His name was Heinz Guderian. Guderian's reputation would become tied forever to the word blitzkrieg, but his real sight was not simply that tanks should move fast. Many officers understood that tanks were mobile. Guderian understood speed meant nothing without communication. A tank alone was a vehicle. A tank connected to other tanks, infantry, artillery, reconnaissance, and command was part of a system. In 1937, in his book Achtung Panzer, Guderian argued for armored units that could move, report, react, and coordinate. Radio was central to that vision. Without it, tanks risked becoming a herd of machines waiting for flags, hand signals, dispatch riders, or prearranged plans. Germany entered the war with a serious appreciation for radio. That must be said clearly. The German army was not a primitive force shouting into the wind. German armored doctrine valued radio deeply. German tanks often carried radio equipment, and German commanders understood that communication was essential to fast-moving warfare. In 1939 and 1940, this helped Germany defeat Poland and France with shocking speed. But there was a difference between understanding the idea and sustaining the system through a long industrial war. The German army had radios. The American army would eventually have more radios in Sexpol, in more vehicles, with better resistance to battlefield noise, tied into a larger and more flexible command network. That difference would grow more important every year. In the early victories of the Wehrmacht, the weaknesses were easier to hide. Poland had far less modern equipment. France and Britain had serious command and doctrine problems of their own. German armored formations could often act faster than their opponents, even when German equipment was imperfect. But war has a way of exposing every hidden weakness. And by 1941, the United States was still not yet in the war, but American industry was already preparing for the possibility of one. At Fort Monmouth, New Jersey, at Bell Telephone Laboratories, and inside American radio companies, engineers worked on military communication systems that could survive the conditions of modern combat. At one of those systems would become the SCR-508. It was not small, it was not elegant, it was heavy, complex, and built for vehicles. But for American armored units, it became one of the most important pieces of equipment inside the tank. The SCR-508 family used FM. It operated in the lower VHF range, roughly between 20 and 27.9 megahertz. It gave American tank crews a relatively clear voice link in conditions where AM radios could struggle badly with electrical interference and noise. Inside a Sherman tank, this mattered. The Sherman's gun was not always superior. Its armor was not always superior. Against a Panther or a Tiger, from the front, a standard 75mm Sherman could be badly outmatched. But the Sherman was reliable, available in huge numbers, easier to maintain than many German tanks, and, just as importantly, it was built as part of a communication system. A Sherman platoon could talk. A company could coordinate. A battalion commander could shift units, request artillery, receive reports, redirect reconnaissance, and react faster than an enemy who had lost contact with half his formation. This did not make the Sherman invincible. It made the Sherman dangerous in groups. And American war-making was built around groups. While Bell Labs and the Signal Corps worked on tank radios, another story was unfolding in Chicago. In 1939, a Polish engineer named Henryk Władysław Magnuski traveled to the United States. He was supposed to study American radio designs and return to Poland. But on September 1, 1939, Germany invaded Poland. On September 17, the Soviet Union invaded from the east. Poland was crushed between two powers. Magnuski could not safely return home. His country had been occupied. His future had been erased in a matter of weeks. In 1940, he joined the Galvin Manufacturing Corporation in Chicago. Galvin made car radios under a brand name that would soon become famous, Motorola. There, under the direction of Daniel E. Noble and with a team of engineers, Magnuski helped develop one of the most famous portable military radios of the war, the SCR-300. Soldiers would call it a walkie-talkie. It was not a toy-sized handheld device like people imagine today. It was a backpack radio, heavy by modern standards, but revolutionary for infantry communication. It used FM and operated around 40 to 48 megahertz. That gave American infantry officers and forward observers something incredibly valuable: a clear, portable voice radio that could move with them through mud, hills, towns, forests, and battlefields. But there was a problem. The SCR-508 tank radio and the SCR-300 infantry radio did not operate on the same frequencies. The tank could talk to tanks. The infantryman could talk to infantry and some command nets. But the man walking beside the tank could not simply speak into his SCR-300 and be heard by the tank commander inside the Sherman. And two excellent American radios existed side by side. And in some of the most dangerous fighting of the war, they could not talk directly to each other. That flaw would cost lives. But before Normandy revealed it fully, the American Army had to learn other lessons first. In February 1943, at Kasserine Pass in Tunisia, the United States Army met the German Army in one of its first major battles in North Africa. The result was painful. The Americans were inexperienced, their units were poorly positioned, their commanders often failed to understand the ground. Tanks were separated from infantry. Infantry was isolated on hills. Artillery was not always used effectively. German commanders, including veterans of the Desert War, exploited these weaknesses with brutal speed. Kasserine became a humiliation. American units were pushed back. Men were killed, wounded, or captured. Equipment was lost. Commanders were relieved. Doctrine was re-examined. But defeat is also a teacher. And one lesson the Americans carried away was that communication could prevent defeat from becoming disaster. Even when units were scattered, the ability to send reports, redirect forces, call for artillery, and coordinate withdrawals gave American formations a chance to recover. The radio did not save Kasserine. It did not turn defeat into victory. But it helped show American officers what a real communication network could do under pressure. The American Army learned quickly, because it had to. By the summer of 1943, in Sicily, American and Allied forces began using these communication systems in a larger amphibious campaign. The SCR-300 entered combat use. Tank radios linked armored units. Artillery observers, infantry commanders, and vehicle crews became part of a growing web of voice communication. It was not perfect. Nothing in war is perfect. Radios failed, batteries died, antennas broke, frequencies became crowded, terrain interfered. Men misunderstood orders. Units still blundered into danger. But compared with older methods of battlefield command, the improvement was enormous. A lieutenant pinned down by fire could call for help. A tank platoon could report enemy movement. A forward observer could bring artillery onto a target without sending a runner through shell fire. A commander could hear the battle changing while there was still time to act. This was the real power of radio. Not that it made men smarter. It made information move faster than fear. By 1944, the war had reached France. On June 6, Allied forces landed in Normandy. American Shermans came ashore into a battlefield of smoke, water, mines, artillery, and death. Radios linked tanks to other tanks, command posts, artillery networks, naval fire support channels, and the wider invasion system. But as the army moved inland, it entered one of the worst landscapes in Europe for tanks. The bocage, the hedgerow country of Normandy, was a nightmare made of earth and roots. Fields were divided by high embankments, topped with thick hedges. Visibility was often terrible. A tank could be safe one moment and dead the next. German infantry could hide with Panzerfausts and Panzerschrecks at close range. Anti-tank guns could wait behind gaps in the hedges. In open country, a Sherman's radio network was a strength. In the bocage, another problem became deadly. Infantry and tanks needed each other more than ever. The infantry could spot German anti-tank teams hiding near the hedges. The tank could provide firepower the infantry desperately needed. But the infantryman outside the tank could not always talk directly to the tank crew inside. He might see a German soldier preparing a Panzerfaust shot. He might shout. He might wave. He might fire his rifle. But inside the Sherman, with its engine roaring, its hatches closed, and enemy fire striking around it, the crew might never hear him. The Americans had built some of the best tactical radios of the war. Yet here was a simple, ugly gap. The man beside the tank could not easily speak to the man inside the tank. And so the soldiers improvised. They took field telephones. They took wire. They took empty ammunition boxes. They welded boxes to the rear of Sherman tanks and connected the phone to the tank's internal communication system. Now an infantryman could run up behind the tank, open the box, pick up the handset, and speak directly to the crew. It was not advanced technology. It was not elegant. It was not designed in a laboratory. But it worked. And in Normandy, it worked was the only standard that mattered. This was one of the truths of the American war effort. The advantage was not just invention. It was adaptation. When a flaw appeared, soldiers and mechanics often found a field solution before the official system caught up. The hedgerows slowed the Americans. They bled them. They exposed weaknesses in tactics and communication. But the American Army learned. By late July 1944, Operation Cobra began. The goal was to break through the German lines near Saint-Lô and escape the bocage into open country. The operation opened with a massive air bombardment. It caused terrible destruction among German units, especially Panzer-Lehr Division, though it also killed American troops in tragic friendly fire incidents. Once the line cracked, American armor poured through. Now the communication advantage became far more visible. In open terrain, armored columns could move quickly. Reconnaissance could report routes. Commanders could redirect battalions. Artillery could shift fire. Engineers could be sent where bridges were needed. Fuel and ammunition could follow the spearheads. This was not just the story of radios inside tanks. It was the story of an army whose moving parts could talk to one another. German units were still dangerous. German soldiers still fought hard. German anti-tank guns still killed Shermans. Panthers and Tigers were still feared. The Germans remained tactically skilled, especially in defense. But they were increasingly fighting a war of broken connections. Telephone lines were cut by bombing and artillery. Command posts moved or were destroyed. Fuel shortages immobilized units. Air attacks made daylight movement dangerous. Replacement crews were less trained than earlier in the war. Orders arrived late or not at all. A German tank company might have excellent guns and brave crews, but if it did not know where the enemy was, where its own infantry had gone, whether fuel was coming or what the neighboring unit was doing, its strength could be wasted. A tank with a powerful gun is dangerous. A tank without information is waiting to be surrounded. In August 1944, the German front in France collapsed. Patton's Third Army raced east. American columns moved at speeds that would have been impossible without radios, trucks, engineers, fuel organization, air support, and aggressive command. Some units advanced dozens of miles in a day. Again, radio did not create the fuel. It did not build the trucks. It did not repair the bridges, but it helped coordinate the machine that did. In September 1944, near Haraucourt in Lorraine, the difference between machines and systems became clearer. The Germans launched counterattacks with Panther tanks, some of the most formidable armored vehicles of the war. On paper, a Panther was superior to a standard Sherman in armor and long-range firepower. Its high-velocity 75mm gun could kill Shermans at ranges where many Shermans struggled to penetrate its frontal armor. But the battlefield is not paper. Around Haraucourt, fog, terrain, surprise, artillery, aircraft, reconnaissance, and command all mattered. American units of the 4th Armored Division, including forces associated with Creighton Abrams, fought with coordination and flexibility. German armored brigades, many newly formed and not fully trained as combined arms teams, attacked under difficult conditions and suffered heavily. American tank crews used movement, flank shots, artillery, tank destroyers, and radio coordination to offset German armor advantages. The result was a major defeat for the German counterattack. The exact numbers vary depending on the historian and what is counted, but German armored losses were severe, while American losses were much lower than German commanders had hoped. Haraucourt does not prove that the Sherman was a better tank than the Panther. It proves something more important. A good tank used poorly can lose to a weaker tank used well. And a connected force can defeat a more heavily armored force that cannot coordinate effectively. That was the pattern repeating across Western Europe. The German army still had moments of skill and ferocity. In the Ardennes, in December 1944, it shocked the Allies with a major offensive. American units were surprised, some were overrun. The weather grounded Allied air power for a time. German columns advanced through fog, forest, and confusion. Even there, communication helped the Americans recover. Units that were cut off could still sometimes report. Commanders could shift reserves. Artillery could be massed. Roadblocks could be organized. Once the weather cleared and Allied air power returned, German movement became increasingly impossible. The Battle of the Bulge was not won by radio alone. But without communication, the Allied response would have been slower, clumsier, and far more costly. By March 1945, the war had reached the Rhine. The Rhine was Germany's last great natural barrier in the West. The Allies expected most bridges to be destroyed. Crossing would require planning, engineers, assault boats, pontoon bridges, artillery preparation, and air cover. Then, on March 7, American forces reached Remagen. The Ludendorff Bridge was still standing. Damaged, dangerous, and wired for demolition, but standing. This was the kind of opportunity that lasts minutes, not days. The message moved quickly through American command channels. Frontline troops reported the bridge. Higher headquarters understood the importance. Units were redirected, engineers were sent, anti-aircraft defenses were moved, reinforcements were pushed toward the crossing, and the bridge was captured. German attempts to destroy it continued. Artillery, aircraft, rockets, swimmers, demolition efforts, everything was tried. The bridge eventually collapsed on March 17, killing and injuring American engineers working on and around it. But by then, the Americans had already used the bridgehead. Additional crossings and pontoon bridges were being established. The Rhine barrier had been broken. Again, this was not just radio. It was initiative, engineering, courage, and command. Radio gave speed to decision. And in war, speed can turn an opportunity into history. On the German side, the situation was collapsing. Orders were issued from headquarters that no longer had a clear picture. Units existed on maps that no longer existed in reality. Telephone lines had been cut. Radio networks were overstrained, vulnerable, or insufficient. Fuel was gone. Roads were under air attack. Commanders could not move freely. Reports arrived late, incomplete, or not at all. The German army was not defeated because it never understood radio. It was defeated because by 1945, it could no longer maintain the kind of communication, mobility, supply, and command system needed to fight a modern coalition army with overwhelming material superiority. Inside the Ruhr pocket, in April 1945, this became final. Army Group B, under Field Marshal Walter Model, was surrounded by American forces. Hundreds of thousands of German troops were trapped in the industrial heartland of Western Germany. Model was one of Hitler's most trusted offensive commanders. He had a reputation for rescuing collapsing fronts. But by April 1945, there was no front left to rescue. His army was cut apart. His communications were failing. His divisions were isolated. His soldiers were hungry, short of ammunition, short of fuel, and increasingly aware that the war was lost. A commander can give orders only to an army that can receive them. When communication breaks, an army becomes fragments. On April 17, 1945, Model dissolved Army Group B. He did not stage a formal surrender as a field marshal. He released his soldiers to attempt escape, go home, or surrender individually. 4 days later, he walked into a forest near Duisburg and took his own life. The collapse of the Ruhr was not caused by radios alone. It was the result of strategic encirclement, Allied air power, fuel starvation, industrial collapse, battlefield losses, and Hitler's refusal to accept reality. But the communication failure made the end feel even more complete. The army could no longer act as one body. Its nervous system had failed. After the war, Allied technical teams examined German equipment, including radios. What they found was not that Germany had ignored communication completely. That would be false. German radio engineering had produced capable equipment. German armored doctrine had valued radio from the beginning. In 1939 and 1940, this helped Germany win. But compared with the Americans, by 1944 and 1945, German tactical radio systems had serious disadvantages. American forces had more widespread radio distribution. American armored vehicles commonly operated within a larger communication network. FM gave American tank radios better resistance to certain kinds of noise and interference. American industry could produce radios, spare parts, batteries, tubes, vehicles, and trained operators in huge quantities. American doctrine increasingly learned how to use those networks for artillery, armor, infantry, air support, logistics, and command. This was the true advantage. Not one radio, not one invention, not one genius in a laboratory. A system. Armstrong's FM made clear battlefield voice communication more practical. Bell Labs and the Signal Corps turned that idea into vehicle radios. Motorola and engineers like Daniel Noble and Henryk Magnuski helped bring FM communication to infantry. American factories produced the equipment at scale. American soldiers adapted it under fire. American commanders learned, sometimes painfully, how to fight with it. That is how technology changes war. Not by existing, by being built, issued, maintained, trusted, and used. The German army built many excellent weapons. It built tanks with thick armor and powerful guns. It built optics admired by its enemies. It produced officers and crews of great tactical skill. But as the war dragged on, German strengths became harder to connect. A Panther without fuel could not move. A Tiger without recovery vehicles could be abandoned. A command post without communications could not command. A brave infantry battalion without artillery support could be crushed. A counterattack ordered too late could die before it began. The Americans, by contrast, were often less elegant, but more connected. Their tanks were not always the best individually. Their soldiers were not born experienced. Their early battles exposed serious flaws, but their system improved. It listened. It reported. It corrected. It called for help. And the voice kept moving. That is why the radio inside a Sherman mattered. Not because it made the Sherman a better tank than a Panther, but because it helped make a platoon more than 5 separate tanks. It made a company more than a collection of vehicles. It made a battalion more than a line on a map. It made an army able to react faster than the enemy could understand. And when the battlefield is smoke, mud, trees, hills, shellfire, and fear, the side that understands first often shoots first. The men who used those radios did not think of themselves as part of a communications revolution. A Sherman commander did not sit in his turret thinking about Edwin Armstrong. An infantry lieutenant carrying an SCR 300 did not think about patents, frequency bands, or corporate lawsuits. A mechanic welding a field telephone box onto the back of a tank in Normandy did not think he was changing military doctrine. They thought about staying alive. They thought about finding the enemy before the enemy found them. They thought about hearing a friendly voice in the noise. That was enough. After the war, Edwin Armstrong's personal story ended in tragedy. He fought long legal battles over FM. He spent years in conflict with RCA and David Sarnoff. In 1954, exhausted and nearly broken, he took his own life. Henryk Magnuski remained in America and continued his career at Motorola. Daniel Noble became one of Motorola's major technical leaders. The radios they helped create became part of a much larger legacy. The modern battlefield as a network of voices, signals, data, and decisions. Today, tanks no longer rely on simple voice radios alone. They use encrypted communications, digital data links, satellite navigation, battlefield management systems, drones, sensors, and real-time targeting networks. But the principle is the same. A tank is not just armor and a gun. It is a node. A soldier is not just a rifle. He is part of a network. An army that can see, hear, report, and react faster has an advantage no armor plate can replace. The Second World War was not won by radio alone. It was won by factories, ships, trucks, aircraft, artillery, fuel codebreakers, engineers, medics, infantry, sailors, pilots, tank crews, and millions of ordinary people doing extraordinary things under impossible conditions. But among all those forces, radio gave something priceless: connection. Told a tank commander where his friends were. Told artillery where the enemy was. Told infantry that help was coming. Told headquarters when the plan had changed. Told men in steel boxes that they were not alone. And the Germans had built formidable tanks. The Americans built a formidable system. And in the end, war is not won by the strongest machine. It is won by the side that can make its machines, its commanders, and its soldiers act together before the enemy can stop them. On the battlefield, hearing is not a comfort. It is survival. And in Western Europe, from Tunisia to Normandy, from Lorraine to the Rhine, the American Army learned how to hear. That was the invisible advantage.